in our effort to take care of the fact that we missed the first week of lab, we're not doing experiment 20 part A, if you recall. We're doing experiment 20 part B. So this week, experiment 20 part B, you should have gotten from your lab prof at least what acid chloride you will be using this week, so you can prepare your pre-lab. There's a report form which goes with this experiment, and so that will be due, so you're going to do the experiment this week. The report form is due next week, so we can look at your data, so that for the following week, when we have lab again, we know if what you made this week is good for part C, okay? So that report form is due Wednesday the 12th, so the Wednesday you get back from winter break if you have a Tuesday lab, or Friday the 14th if you have a Thursday lab, okay? So just keep that in mind, and we'll talk a little bit more about it here in a little bit. You've got a quiz number 4. Next week we don't have lab because you're not in class on Tuesday, we're not going to have lab on Thursday, so there's no pre-lab lecture. So even though Wednesday is Monday's scheduled, go to workshop on Wednesday, not pre-lab lecture. Open lab for next week. So we'll be open Wednesday, 9:30 to 3:30. Thursday, since we don't have lab, we'll be open for open lab from 9 a.m. to 5 p.m. And then Friday will be open, usual 9:30 to 3:30. Okay. Something to keep in mind though for 2 weeks. So the next time after this week you see your lab prof, your experiment 17 report is due. Okay. So be prepared for that when you come back to lab in 2 weeks. That report, which will be going into your notebook, full conclusion, just like last semester, full big report, that is due in 2 weeks. So you want to analyze that NMR data sooner than later. Okay, now we're already to our midterm exam practically. So in the back, I've got the practice midterm exam. If you didn't pick it up on your way in today, make sure on your way out you get that. We will go over that exam on Monday the 17th. So the next time I see you again, we'll talk about that exam. And then on Monday, February 24th, that is the date of the midterm exam from 4 to 5 in here. Everybody getting together just like with the final exam last semester. So make sure that you are here on time. We'll start right at 4 o'clock. It's an hour exam. If you have any academic support center paperwork or any paperwork of that type that you need filled out for the exam, see me. Don't see your lab prof. See me, because I'm the one who will end up delivering those exams where they need to go. So make sure you see me to sign the paperwork, and see me before lab lecture before I see you again, okay? So if you do have paperwork, make sure I sign it before the 17th, so we've got everything set up for that, okay? So what I'm going to do right now is, even though we're missing experiment 20 part A, I still need to give you some background of this whole experiment so you understand where this is coming from. So you should still read the introduction to experiment 20, and I would read through even part A so you have a feel for what would have happened had you done experiment 20 part A, and what type of products you would have been making from experiment 20A. We're just going to use one of the products you would have made for part B. So in the experiment, it's a case study where we are trying to eventually make these 3 compounds. These are the desired compounds of the case study. And so these technicians at Enzotech, this pharmaceutical company, have found these are active, potentially active pharmaceutical agents, and we want to, or they're on their way to active pharmaceutical agents, and we want to make the precursors to them because right now they're getting them out of onions and leeks and garlic, which is not very pleasant, okay? So just keep in mind that this is where we eventually want to get to, okay? Because we'll be revisiting this again with 20C. So the whole scheme for experiment 20, part A, we would have started with 4-hydroxybenzoic acid, okay? And you would have done a Fischer esterification with either methanol, ethanol, or 1-propanol to make one of these compounds, with the R prime being what varied, depending on what alcohol you started with. So if you haven't started carbonyls yet in lecture, you will very quickly, and this is a reaction that you will cover when you discuss carbonyl chemistry, okay? So what we are going to do is we have, you can readily buy the methylbenzoate ester, okay? So methyl 4-hydroxybenzoate you can purchase. And so everybody this week will be starting with the methyl 4-hydroxybenzoate, so R prime is going to be methyl for everybody for this experiment, okay? So for this week and next week, your R prime is methyl, all right? So then this week, we are going to make an ester. We've got an ester here. We're going to make this compound then into a diester. We're going to have an ester on either side. The attachment's just going to be a little bit different on this side as it is than what is going on this side. And so to do that, we're going to take our methyl 4-hydroxybenzoate. We're going to react it with an acid chloride in the presence of pyridine, and then we will get our diester, okay? And so where your acid chlorides come into play is what R group you are supposed to have. So the way this ester forms is there's actually a carbon here and then this R group off of here to make the ester. The R is pertaining to just this group here. So we want a methyl here, not meaning that we've only got one carbon here. For the methyl, we would actually have 2 carbons, okay? So we want either a methyl, ethyl, or propyl group here. So for methyl, you'll be using acetyl chloride. For propyl, you'll be using propionyl chloride, or sorry, for ethyl, methyl acetyl chloride, ethyl propyonyl chloride, propyl, you'll use butyryl chloride. So you always need one more carbon than just the chain for that acid chloride, okay? And then in 2 weeks, when we see you again, we'll take your diester that you make this week, and we're going to add it to either orange peel esterase or pig liver esterase. We're going to add an enzyme to it and see which end gets eaten up, okay? So this is where we're going to end for this week. So if you looked in experiment 20 in your lab manual, because we're only going to use the R prime methyl groups, basically, instead of having 18 technician possibilities for this experiment, so had we had all possibilities, basically every class would have one of each with maybe a duplicate or 2. We're going to narrow it down to 6 possibilities. So everybody's going to have R prime is a methyl group. Then here is where your acid chloride comes into play, whether you're making the methyl group, ethyl group, or propyl group. And then in 2 weeks, which enzyme you're going to use to see if your diester gets chewed up and which end of it gets chewed up, okay? Everybody okay so far? Okay, so that was kind of the quick introduction of experiment 20. Couple things I want to go over before we talk about 20B's reaction are we want to, first of all, for part B and part C, you're going to have certain pieces that you put into your notebook. So for your notebook, you're going to have a pre-lab for each part. So you want to write the pre-lab that you write for this week, you want to be for just 20B, not 20C as well. Okay, so an individual pre-lab for part B and then an individual pre-lab for part C. You're going to have, as usual, your experimental. Then you're going to write a mini conclusion after you get your data back. So you're going to have yield, you're going to potentially have melting points, you're going to have IR data, you're going to have NMR data. Once you get that data back in your notebook, before you start part C, you need to have written a mini conclusion that summarizes that data that you collected. So it's not a full conclusion, it's just a paragraph or 2 that summarizes the data that you collected, and you want to state, is it okay that you go on to part C, or are there issues that need to be addressed before you go on to part C, okay? Or at the end of part C, what were your conclusions for just part C, okay? So these 3 parts need to be in part B and part C, okay? Then you're going to write an overall conclusion for parts B and C, and also for part C's data analysis. So that table that I just showed you, we're going to go back, and the week of lab, after you take the midterm, so that Tuesday and Thursday after the midterm, we're going to look at everybody's data for part B and part C and go through some data analysis. So this final conclusion that you're going to write is going to be a conclusion where you summarize B and C together, looking at them as one experiment with 2 parts, and then you'll look at the data analysis and the data that you collect, the class collects for part C, okay? So this one won't be due for a while. These 3 you want to make sure that you do for both B and C, all right? And then this one will be due like the week of midterm. Another thing that I want to let you know about, so our starting compound that we're starting with is this guy. What I have done is I decided to, in what you got from us last week as far as the instructions for the experiment, it said to use 1 gram of this to start the experiment. I'm afraid that you won't quite have enough material to do all that you need to do with part B and all that you need to do with part C. So what I want you to do is use 1.5 grams of this to start your experiment this week, okay? So then you'll base your calculations for your acid chloride and for your pyridine based on using 1.5 grams, okay? When you weigh it out, if you get like 1.56 grams, that's fine. It's better to be a little bit over than to be a little bit under. So as you're quickly getting your solid weight out, if you weigh out, 1.57, 1.6 grams, you're okay to go with that. Just make sure you adjust your calculations for your acid chloride and for your pyridine, okay? So everyone note, you're going to start with 1.5 grams of your methyl 4-hydroxybenzoate, okay? So what I'm going to do now is go through the actual reaction, and then we'll look at the mechanism. And so the reaction itself, you're starting with this. This is a solid compound. You're going to dissolve it in ether. Then you're going to add pyridine to that mixture, and then you will be adding your acid chloride via syringe, okay? And so from this whole mixture, you will then get your diester. And so the actual mechanism is this, and let me just write on here a couple page numbers really quick. So this mechanism is also in McMurray. So the McMurray 6th edition, it's on pages 784 and 785. The 7th edition, it's on pages 802 and 803, okay? So if you want to look for more information about preparation of an acid chloride from, or preparation of an ester from an acid chloride, this is the pages to look at in McMurray. So this, this reaction is known as alcoholysis. So we're reacting here at this alcohol and then converting it to the ester. And so very typical of carbonyl chemistry, we're going to take a nucleophile, we're going to attack the carbon of the carbonyl, and then we will add that acid chloride on to what was the hydroxyl group. we'll now add that acid chloride on. We've got a positive charge here and a negative charge here, so they kind of counterbalance each other. But right away with this reaction, we've got the electrons of the oxygen kicked down and we lose our chloride ion, okay? But then we still have this positive charge on the oxygen that was once part of the hydroxyl group, all right? So we need to take care of that positive charge. And so what we're going to use is pyridine. It will deprotonate our oxygen here, and then, so deprotonation will go on and form our ester just like we wanted, okay? And then we get the pyridinium ion and chloride salt that is then formed, okay? So it's no longer pyridine. Once it reacts, it's pyridinium ion that's counterbalanced with the chloride, all right? And so, couple things that we need to keep in mind is just like the OH group can react with the acid chloride, water can react with that acid chloride. Okay, so we need to keep things as dry as possible. So you want to make sure that you're using a dry flask, dry stir bar. All of the other equipment we're going to provide is dry for you. You're going to use dry ether. And that is going to be in the reagent hood, so don't use the red can ether for setting it up. And you want to keep things as dry as possible, so keep the acid chloride dry. Keep the pyridine dry. And just be really careful that you don't introduce any water into the reaction at all, okay? Because it will react with your acid chloride instead of reacting, your acid chloride then reacting with the hydroxyl group of the ester. With this too, there's a reason that we use pyridine instead of some other type of base. So can you think of how this base is related to other things we've used before? Yep, it's a non-nucleophilic base. So just like which experiment? Do you recall? Experiment 7, right, with the quinoline? Same idea. So we need a non-nucleophilic base, and why would that be? So you don't attack that carbonyl, right? So just like we talked about water, any OH group, so KOH, NaOH, it can attack the carbonyl instead of going on and deprotonating the product that you form, okay? So you need a non-nucleophilic base for this reaction. A couple other things to consider are bulky groups slow the reaction down. And so preferably you want to use a primary acid chloride, then secondary would be next, and tertiary is going to really slow things down. But you can use this to your advantage. So the more bulky things are, and the more hindered things are, the less reactive they're going to be. So you could have a competition of something that is less hindered. It will react first over something that's really bulky. So you can also use this to your advantage if you have multiple groups on the same compound. Okay. Now, with what we are going to use this week, we've got to consider some hazards and precautions that we need to take into account. So the acid chlorides are lacquer makers. So what does that do? It can it'll react with any moisture that you have. So it'll react with your tears, it'll react with your saliva, react with any of your moist membranes, right? So it'll irritate your eyes, irritate your nose, and so forth. So keep these in the hood. You don't want these out floating in the air. You want to make sure I'd wear gloves when you handle them. Make sure that you don't rub your eyes or anything like that when you're handling them because they'll irritate you very quickly, okay? They also stink. Some stink worse than others, okay? And so the stinkiest of them all is the butyryl chloride. And what happens is, what causes the stink is not the acid chloride, it's the reaction of the acid chloride with water. So if you take the butyryl chloride, react it with water, you get butyric acid. Well, butyric acid is what is the smell in rancid butter. That is the stench of rancid butter, okay? So it's really, really quite stinky, okay? So we need to contain the acid chlorides, keep them in the hoods. Any stinky garbage from the acid chlorides, you want to make sure you dispose of those. We'll have plenty of garbage bags in hoods, not dispose of them in the common garbage, because it doesn't take a whole lot to make the whole lab stink, okay? So be really careful with anything that you get acid chlorides on, that we contain that and not make the entire lab stink. And then we talked about, which this shows, there is the water reactivity, okay? Pyridine is not the greatest thing either, okay? It's a toxic chemical. You don't want to ingest it, okay? And it stinks too. And so keep it in the hood. Wear gloves. Be careful how you handle it, and don't. It can also react with water as well, so you don't want it to get wet. And then make sure you contain any of it stinky garbage. Okay. So this is going to be the test this week. How well can you contain stinky garbage? Because we'll know immediately if someone is not. And we all know what we assigned you, so we know this stinks, so we can pretty much figure out who's making it stink too. So keep everything stinky in the hood. Wear gloves. Be careful handling it. Don't get it on you. Okay. Now the setup that you're going to be using, and we've got kind of demos in the lab as well. You're going to use your 50 milliliter round bottom flask. Okay, and you can't laugh at my artwork here. You're going to put on this flask what is called a septum. Okay, and so it goes down into the flask itself, and then it folds this rubber piece that goes into the flask, and then it folds over the edges of the flask. Okay, so we'll show you. It's kind of a test in dexterity and coordination too, how well you can get these on your flask. Then we're going to have on the flask itself, we're going to have a vent needle, because part of this reaction is it's going to give off a little bit of HCl gas, okay? So we need a vent needle. This vent needle is a purple needle. So we've got two different needles. We've got a yellow one and we've got a purple one, okay? So vent needle's purple. So then, when you have your methyl 4-hydroxybenzoate in your flask, you have your ether in your flask, you have your stirbar in your flask, you have your pyridine in your flask, cap this with a septum, stick the vent needle very carefully. Don't stick yourself, but stick it into the reaction flask, okay? At this point, once you have everything dissolved and everything stirred the way it's supposed to, then you're going to get your acid chloride. And because of the stink, and because we don't want to get multiple people carrying acid chlorides around the room, either your instructor or your TA is going to dispense of your acid chloride, okay? So the other color needle is the yellow one. It's going to be off of the syringe that's going to be used to put your reaction, or put your acid chloride into your reaction, okay? So this is the yellow needle, all right? You're going to add your acid chloride dropwise, okay? okay, from the syringe. So we are going to dispense of the acid chloride and stick the syringe into your reaction, and then you are going to carefully use the syringe and add that acid chloride dropwise to your reaction. So you don't want to add it all at once. You want to add it dropwise, okay? Then you want to kind of see how you're stirring, okay? Because sometimes these acid chlorides help make so many salts that it's kind of hard to get things to stir. So if you're having trouble with stirring, then you may need to add an additional 5 milliliters of dry. We still are doing this reaction, so we want dry ethyl ether, okay? So to do that, now we've got this reaction flask with all sorts of pokey things sticking out of it, and now we got to get into it, okay? So you're going to carefully pull your syringe and needle out, carefully pull your vent needle out, undo the septum, add the ether, put the septum back on, put the vent needle back in, okay? Because you don't need your syringe and needle anymore. You've already added the acid chloride, okay? Then you're going to try and get things stirring as best you can. And then what we need to do is warm the reaction in a warm water bath, okay? For about 15 minutes. Now when we're talking warm, not hot, okay? Because remember, we've got ether in there, which, what's the boiling point of ether? 34, 35, right? Not very much, not very hot, okay? So you want this warm water bath 30 degrees or so, okay? You don't want to be distilling any ether out. You don't want to be refluxing any ether, okay? So you just want a warm water bath. So use the hot tap water, but you're probably not going to have to heat it much after that. Just keep it just below the boiling point of the ether so you don't actually boil the ether away, okay? So you're going to heat the reaction in the warm water bath, and then what you need to do is you're going to do a series of washes. And we have you do these for a reason. We're not having you do this just for the heck of it, okay? And so we've got 4 washes that you're going to do. You've got a saturated sodium chloride wash. We've got an HCl wash. We've got an NaOH wash. And we've got another saturated sodium chloride wash. Okay, so we've got these 4 washes. And when we mean wash, so when you're done with the reaction, we tell you to then add 10 milliliters of ether to the reaction. At this point, your reaction's done. Okay, so at the end, when you get to the workup, then use red can ether, okay, not the dry ether. When we say add wash, you're going to, in your step funnel, you're going to have your organic layer, you're going to add the 10 milliliters of sodium chloride, you're going to shake and vent, you're going to drain the aqueous layer, and the organic layer will stay in the step funnel. That is all meant or implied by saying wash. All of those steps are involved in a wash, okay? So then we go on to do the same with HCl, NaOH, and saturated sodium chloride again, okay? So this guy, we're doing, because we're going to, we need to get rid of whatever remaining acid chloride is left, okay? So we need to basically kill or quench your acid chloride, okay, and quench your reaction. So now the acid chloride has reacted with water. We have the carboxylic acid equivalent of it, but we don't have the acid chloride around to react anymore. Then we need to we're going to quench whatever remaining pyridine is left, okay? So that's what that HCl wash is for. Then this guy is to get rid of, so our sodium hydroxide wash is to get rid of remaining starting material. So your methyl 4-hydroxybenzoate okay. So what do you think it's attacking when you're getting rid of it? What's going to be the most vulnerable part of that reaction, or that product there, starting material? So you're going to deprotonate here, right, to make it water soluble. So we need it to get rid of any starting material. The problem with the NaOH wash is it also likes to attack esters, okay? And so once it's done chewing on whatever remaining starting material you have, it can actually go and hydrolyze your esters. And now we've not only got one, but you just made another one, okay? So this wash you've got to do fairly quickly, okay? So when you're ready to do the wash, add the sodium hydroxide, shake and vent a few times, and then quickly drain away that sodium hydroxide, okay? Quickly drain away that aqueous layer and get it away from the organic layer. We want it to mix together enough to get rid of our starting material, but we don't want it doing anything to your esters that you formed, okay? And then the saturated sodium chloride wash is to help get rid of any remaining, you can help with any remaining water, help pull that out, and you'll get like the last little bit out with magnesium sulfate. It also helps get the remaining sodium hydroxide out and away from it too, okay? So you want to do this wash quickly, and then quickly follow it with the sodium chloride wash to make sure all that sodium hydroxide is away from your product, okay? Then at this point, we need to TLC your reaction, okay? And we want to see what we've got and see if we've gotten just our product out and gotten rid of all the things that we wanted to get rid of with the washes. So we have a standard TLC, or a TLC standard for your starting material. And then you're going to TLC just your organic layer once you finish with these washes. So what you'll do is just on the TLC plate, you're just going to spot two things. So you can use the skinny TLC plates for here. You can put your standard on one side and your reaction mixture on the other, okay? And our eluent is kind of a different eluent than we've used so far. It's 95 dichloromethane and 5 methanol. So then you'll develop this TLC plate, okay? If you have a lot of reactant still left in your reaction mixture, then we need to go through these washes again to get rid of, we don't need to do the HCl wash again, but we need to do the sodium hydroxide wash again, and then do the saturated sodium chloride wash again, okay? So if you have starting material left, and you probably will want to double check with your lab instructor to see if it's enough worth doing all these washes, but if you're seeing it by TLC, if you have starting material left, then you're going to do NaOH wash again, and the sodium chloride wash again, okay? And then you're going to TLC again, all right? If you don't have any starting material left, then you're going to go on dry with magnesium sulfate, gravity filter, And then you'll rotovap and put your stuff on the high vacuum pump. If you have starting material left, then once you go through the second set of washes, have your instructor look at your TLC plate. And most likely, we probably won't have you do a third set. You'll then continue on to dry with magnesium sulfate, do the gravity filtration, rotovap, put it on the high vacuum pump. Okay, and remember, before you rotovap, know the tare weight of your flask so you can get yield. The magnesium sulfate and filter paper from the drying, that should go in a bucket that's in the hood itself. Okay, and then everybody, the butyric acid or butyryl chloride people will need to use, there's a rotovap in 3129 in the hood. You'll want to use that for your rotovapping, and then you'll want to use the high vacuum pump in 3129 for your high vacuum, for putting it on the high vacuum pump. Okay, so we're trying to isolate the stinkiness. All right. Then for analysis, you'll need yield. You'll need to collect an IR spectrum. You'll need to make an NMR sample. So remember to clean out your NMR tubes. And if you have a solid, then you need a melting point. So these 4 things need to be collected from your data, all right? And the solid, it's just dependent on if you have a solid or not, whether you get a melting point, all right? And then in a minute here, we'll go through what the report form looks like. We'll talk about where you're going to report all this information, okay? And then you also do have the TLC analysis of your crude product as well, all right? Questions on the reaction itself? Okay, couple things I need to go over for the reaction is you have to make some calculations. And you have to make those calculations based on what you are starting with. So remember, we're starting with 1.5 grams of methyl 4-hydroxybenzoate. So you first of all need to convert this to moles. Okay. For the purity, you're supposed to use 1.7 equivalents of your starting material. Okay? And so what that means is 1.7 times the number of moles of starting material. Okay, so you convert to moles, and then take 1.7 times the number of moles of starting material, and then that is how you take into account the equivalents. You convert to grams from moles, and then convert to volume, because pyridine is a liquid, so you know how much weight to measure out. Okay? That's how you calculate how much pyridine you're going to use. And put these calculations in your notebook, so if we have questions, we can see them and look them over. For the acid chloride, you're supposed to use 1.5 equivalents of your starting material. So again, 1.5 instead of 1.7 times the number of moles of starting material. And you're going to convert to grams. And then convert to volume. Okay, everyone good with that? Okay, so this is how you get your volume of pyridine to use. how you get your volume of acid chloride to use. The pyridine itself is going to have its own setup for dispensing. For the acid chlorides, when you go to get what you need out of the reagent hood for the acid chlorides, things are separated of acetyl propionyl chloride separated from butyryl chloride, because there's separate things we need to take care of because the butyryl chloride is so stinky, okay? So when you go to get your septa, your needles, your syringes that you need for setting up your reaction, keep in mind what acid chloride you're using, grab from the right bin, okay? Same with after you clean things up, we need to keep things separate. So if you use acetyl propionyl chloride, put it in the right container. If you use butyryl chloride, put it in the correct container, okay? Now, for cleanup, a couple things we need to take into consideration, especially for the butyryl chloride. We've got to kill the stink, basically. So, for, I'm going to abbreviate A and P. For acetyl and propionyl chloride, you're going to rinse your syringe, needles, and septa with acetone and put it in the right container in the reagent hood. And there's containers for used of all these things in the reagent hood. For the syringes, pull the plungers out. That'll help things dry out so that we can reuse them again for the Thursday lab, okay? And then rinse all your other glassware. And all these rinses are going into organic waste with acetone, and then clean them as you normally would. So rinse it with acetone and then clean it with soap and water, rinse it with water, rinse it again with acetone, okay? For the butyryl chloride, what we need to do is first of all rinse with acetone for all our pieces, okay? We're going to put this in a beaker because we're going to collect this acetone rinse. So your syringe, needles, septa, you're going to rinse first with acetone, okay? Then you're going to rinse with bleach, okay? This is regular household, do your laundry with it, bleach, okay? So if you're using butyryl chloride, probably don't wear your finest wares to lab this week in case you get a little splatter of bleach on it, okay? You're going to rinse it with bleach, and that kills that butyryl chloride stench, okay? So we're going to get rid of that, all right? Then we're going to rinse with water, and then we'll rinse with acetone again, okay? And this is just for the septa, syringes, and needles, okay? So make sure you go through all these steps. This last acetone rinse can just go in the regular organic waste container, but this one needs to go in a separate container, okay, into a beaker. Then this can be returned to the proper place in the reagent hood. The other equipment, rinse with acetone, that goes into that beaker. Rinse with bleach and then water. And then you're going to clean with soap and water like you normally would clean your dishes. And then rinse with acetone again. And again, this final rinse can go into the organic waste container, okay? This beaker rinse we're going to put into a special container that we're going to collect all the butyryl chloride stinky waste in, okay? So once you are completely done, we will retrieve that from you. The bleach itself we'll probably put in one of the large beakers that you have in your lab drawer too, so you've got the bleach. Any rinses with the bleach can just go down straight down the sink, just like you normally would with bleach and water, okay? And then the final rinses with acetone need to go in organic waste, okay? I would always, with butyl chloride, make sure you're wearing gloves, maybe sometimes 2 sets of gloves. And we are also going to give you a garbage bag that you're going to keep right in your hood so we get all the stinky garbage into the right place, okay? Stinky pipettes, stinky garbage, stinky everything is going to go in that container, okay? Questions with any of this part? Okay, so let's look at now, first the report form that you're going to turn in, and then I have some information for you to hopefully help out with your pre-lab too. So your report form, there's 2 pages to it. First page, you fill out this top section, put the structure of what you made. You're going to, first of all, evaluate the IR spectrum. So follow these instructions and answer these questions for IR spectrum. And then you will evaluate your product with the NMR spectrum and make sure you answer these questions. For this report form, you're going to attach your NMR spectrum and all the pieces that go with it, and you will attach your IR spectrum, okay? Then you want to make sure you have an IR table and an NMR table as well, okay? And if you can find literature spectra to compare to, that's always a good idea to do that as well, okay? So if you can find those spectra, you may not be able to find it for all of them, but if you can find it, compare your data to the literature spectrum, okay? So first page is basic information, IR and NMR, and then on the reverse page, you're going to put all your TLC information where it says RFs for 20A. That's just for the standard methyl 4-hydroxybenzoate that you used, okay? So I didn't reprint all new report forms and everything. We're just gonna, that's the methyl 4-hydroxybenzoate, okay? And then this is your product. So give all the information for TLC, and then is there any reason that you shouldn't continue on with the experiment onto part C? Do you have significant impurities that can't be identified? Anything that you feel like would hinder you being able to take this product on and then make something else with it, keeping in mind if there are a lot of impurities, they're probably going to carry on to the next step, okay? And then this, along with your spectra attached and your tables, is what you're going to hand in either for Tuesday lab sections a week from Wednesday or Thursday lab sections a week from Friday, okay? All right, for data to help you, I've got a couple things here. I'm kind of trying to put up both of them, see if we can get both of them today. Okay, so here is all the information for the acid chlorides and for purity. And then, I don't know if I can quite get, see if I can get this to overlap. This first part is the name of your step A product. Well, we know what we're starting with, the methyl 4-hydroxybenzoate. But these bottom names are what you want for naming your final product. So whether you use the methyl for your acid chloride, the ethyl, or the propyl group, you need these 3 names right here for naming your part B product, okay? So I'll let you copy those down. And if you, a couple of other things to keep in mind, page 20-8 of your lab manual. So I didn't reprint a copy of that because you basically need to follow its instructions, okay? So page 20-8, basically it's telling you to set aside 0.1 grams of your part B product. You're going to use that for TLC 2 weeks from now, so compare it to your part C product. So put that in a vial and store it until 2 weeks from now, and we'll make a TLC mixture for it. We'll just dissolve it in some ether, and you'll be able to use it as a TLC standard, okay? So set aside 0.1 grams of your experiment 20 part B product. The other thing is, then there is the information, basically, fill out the report form and turn it in. So we just went through that. And write your mini conclusion before you start 20C, okay? so don't forget to include your mini conclusion in your notebook before you start working on 20C. And then if you have any questions, let me know. Otherwise, once you have that information, you are free to go. Yes?
So just to clarify, the mini conclusion, you just kind of like handwrite it before I put?
Yeah. You can check with your lab prof, but most of us are just going to have you handwrite it. It's just going to be a paragraph or two. And basically, you're just going to put a basic analysis on your IR and NMR data.